function.
One of my favorites.
Yeah, right? I mean, who can't love this?
Oh, yeah.
All right, I'm just going to start by rewriting it, as we often do when we're taking derivatives of sneaky-looking things. Let's rewrite that so I can think of that as all raised to the 1/2 rather than square root. Now we'll take the derivative. As always, you want to look to see what your overarching rule is. You might see that natural log business, but really your overarching rule is some function raised to the 1/2. So that's where I have to start. So I'm going to start with the chain rule. The derivative of the outside, which is 1/2 times that as it is to the negative 1/2, right? That's the derivative of the outside, times the derivative of the inside. So the derivative of the inside now is going to be the derivative of the natural log of 3x. All right, well, using our new little shortcut, the derivative of the natural log of something is 1 over that something, times the derivative of that inside. This is like a chain and a chain and a
Yes,
chain.
you're pretty excited about it, too.
Right?
Yeah, well, it's good.
So the
Yep.
derivative of 3x, which is 3. So you can have chains inside of chains inside of chains, right? All right, I am going to simplify this. Call me crazy, but I'm just going to simplify this. What should I do, Mr.
Well,
House?
I would draw yourself a big fraction bar, and like
Okay.
I think
Should
about
we
like
get rid of negative exponents
Yeah,
just for fun?
sure.
Okay,
So-
so that 2 is in the denominator. This guy I'm going to bring into the denominator. And that is to the 1/2. I could write that as a square root. Let's see, 1 numerator. Oh, look at this. The 3's divide out. That's so satisfying. There's an x left there. I could put that anywhere. Oh my goodness, there's just a 1 in the numerator. That's kind of satisfying.
I like it.
Yeah. So there you go. There's the derivative of this function. So look for the overarching rule. And don't forget, you're not done chaining until you're done with your chain.
Really, another one?
Absolutely. You can. I mean, we're having so much fun here.
Well,
Let's
yes,
just keep
this-
going.
What more fun could possibly be had than finding derivatives of ln and
Yeah. So we have to do some analysis here and figure out what your overarching rule is here.
Well, this is clearly a product, right? I have some guy, something with x in it. This is an exponential piece right here, times some other guy that happens to be a natural log. So I'm going to use the product rule,
I think that's a good idea.
which we're now professionals at using.
We
It's
are.
just the derivative of the first guy. And of course, the derivative of this thing, this is an exponential function, 3 parts, ln of the base
Good.
times the original guy.
Good.
What am I missing?
The derivative of the
The
exponent.
derivative of the exponent, which is 1, but I shan't write it. I say
Good.
shan't a lot when I do these. I never say shan't except when doing videos.
Well, I'm glad that you save it for this. So
Well,
that's
that's all
A
right.
prime,
That's a prime. Now I'm going to multiply it by b.
B,
3x minus 1. We're going to run out of space, I think.
plus,
Plus the first guy,
as is.
that's a, times the derivative of this, which is, of course, 1 over, you still got me? I'm
I
like
do.
almost out of space. 1 over this thing in the parentheses, multiplied by the derivative of this, which is just 3. My God, I have enough space.
You do.
And I can clean that up a little bit, shall
Sure,
I?
why not?
I mean, I just like to, maybe I'll just put some stuff in the numerator.
Yeah.
So f prime of x, not really much I can do here. Ln of 2, which will give me x. Ends up looking kind of messy, doesn't it?
Well, they're just
ln
lots of pieces.
3x minus 1 plus, and I guess I'll just write these upstairs. So I have 3 times 2 to the x over 3x minus 1.
Beautiful.
A lot of pieces, but really it's nothing I certainly can't do any canceling.
Right.
And that is it.
Thank you, Mr. Haas. Let's do one more here. This is just kind of interesting. Now, what if I told you I could just look at that and know the derivative was 5? Would you be impressed?
Well, I mean,
Come on, just say yes.
yeah, okay. I
All
mean,
right.
I could also
The
do the
derivative of this
same
is
little
5.
trick, but yes, very good. Very good.
So
Okay.
let's do it the long way, and then maybe we can see the short way. So
Yes.
the long way, of course, is just to see, oh, this is a natural log of something. So I'm going to take the derivative by doing 1 over that something. And then the chain rule says I have to do the derivative of that something. Well, that's an exponential. So it's the natural log of the base times the exponential term as it is, times the derivative of the inside, in this case the exponent, and that would be 5. And then if I simplify this and just make it one big happy fraction, I have, well, natural log of e is 1. Oh, hold on, that's the numerator, that's the denominator. Those divide to equal 1. I don't even need a fraction, I'm just left with 5.
That is
Now,
amazing. You're like a calculus clairvoyant or something. Yeah.
How did I do all that in my head? The answer is,
Well, you use one of those rules for simplifying logs, where
Right.
you know it's the log of a to the b is b log a. As
Right.
sometimes we
so if I
refer to it.
have, as you just said, right? Oh, well, that didn't work.
Well.
If I have the log of a to the b, remember that's just the same as b times the log of a. Since logs are exponents, when you raise an exponent to an exponent, you multiply the exponents, right? So I could have, before differentiating, I could have just done the little log shortcut, brought the exponent down, and said, all right, really just rewriting this, that's 5x minus 2 times the natural log of e. The natural log of e is just 1, and so the derivative of this is just the derivative of a linear function, which is 5.
Very nice.
The other way to think about that too, of course, is a log and an exponent, the natural log and e, those are inverse functions, so they undo each other. So you're going to undo, the natural log undoes the exponent, and you end up with a 5x minus 2. Thank you.
To motor wins. The Jack